Hello everyone, how are you feeling? I think everything is going on fine by God's grace. We really miss you in the real classroom. If God wills, we can meet the school very soon. And you are watching physics class. Let's move on to our session. In physics, we are in unit 1, electrostatics. I think you all are keep watching the classes. The previous class, you have been watched about capacitor. You have learned about capacitor. What is capacitor? It is a device which is used to store the electric charge and electric energy. It is a charge storage device. Okay. It is used to store electric charge and electric energy. It consists of two parallel plates or two conducting objects separated by a very small distance. The symbol is two parallel lines. And it has the capacitance C, that is equal to Q by V, the ratio of magnitude of charge on either of the conductor plates to the potential difference existing between the two conductors. And the unit of capacitor is farad. You may have asked about capacitance of a parallel plate capacitor, energy stored in the capacitor, and applications of capacitors. And today's video we are going to discuss about effect of dielectrics in capacitors. Effect of dielectrics in capacitors. What is meant by dielectric? It's a non-conducting material. That means insulator, isn't it? It's a non-conducting material. It has no free electrons. It is an insulator. For example, glass, mica, ebonite, and so on. Isn't it? So when you place a dielectric in capacitor, what will be the effect that we are going to discuss today? Usually, the capacitor you have learnt the separation between the two plates is filled with air or vacuum. Isn't it? The space between the parallel plates of a capacitor is either empty or filled with air. Isn't it? Suppose a dielectric is inserted in between these plates. What will happen to its capacitance? What will be the effect that we are going to discuss? This effect we are going to discuss on the basis of battery connection. Okay, that is when the battery is connected to the capacitor as well as when the battery is disconnected from the capacitor. With these two ways we are going to analyze. The first one, when the capacitor is disconnected from the battery. The first one, when the capacitor is disconnected from the battery. So let us consider the capacitor which is having the cross-sectional area A. It has the two parallel plates, so it has the cross-sectional area A and are separated by the distance D. Okay. So I can draw, this is one of the plate, this is another plate, two parallel plate. So this has positive and this has negative. So two parallel plates having the cross-sectional area A. So A be the cross-sectional area. And the separation between the two plates is considered as D. Okay. Now, first we can consider this capacitor is charged by means of a battery. Okay. So when the battery is connected to this capacitor, Let us say this is the battery. So this capacitor is now gets charged. The capacitor is charged by this battery. Here the battery voltage is taken as V0. Okay. The battery voltage is taken as V0. So because of this battery, the charges are stored to this capacitor. Okay. So the charge stored is taken as Q0. Q0 is known as charge. Charge stored in the capacitor. So what will be the capacitance? In this case, capacitance is considered as C0. C0 is equal to Q0 by V0. Why we are representing as 0 as here we are not introduced the dielectric. So without dielectric we have considered first. Without dielectric. So capacitance of the capacitor without dielectric is C0 is equal to Q0 by V0. Now we know that here the electric field, that lines we can draw from positive to negative. This is the electric field. That can be considered as E0. It's a vector quantity. E0. Understand? Now we are going to introduce the dielectric in between these parallel plate. First we have considered only the capacitor with a battery. Now we are going to introduce the dielectric between the two parallel plate and the battery is disconnected. Okay. So two conditions, that is when the capacitor is disconnected from the battery. So this is the parallel plate. Here first we are removing the battery. First there is a battery connection. This battery connection gets removed and we are introducing a dielectric in between these two parallel plates. So this is the dielectric and insulator. Okay. Now what will happen when we introduce a dielectric in between these two parallel plates? It will decrease the electric field because it is a non-conducting material, isn't it? It is a non-conducting material. So here it will decrease the electric field. So we have to draw the electric field line here with a less number than the previous number. This electric field we can consider as E vector. Previously I have drawn so many lines. Okay. And the electric field is taken as E0 or E0. Now the dielectric is introduced between these two plates. When you introduce the dielectric, the electric field gets decreases. Okay, electric field, because it is a non-conducting material, so the electric field gets decreases. It is an insulator. So now there is a modified form of electric field produced, that is taken as E vector. So now the new electric field is taken as E vector. This can be written as E0 by epsilon r. E0 by epsilon r, where epsilon r is known as the relative permeability of the dielectric. Relative permeability of the dielectric. Okay, this you may have learned in the previous classes and all. Already we know epsilon r is equal to E0 by E. That is the ratio of electric field without dielectric to the electric field with the dielectric. Okay. So we can say the modified form of the electric field E vector equal to E0 by epsilon r, where E0 or E0 is electric field inside the capacitor when there is no dielectric, and epsilon r is the relative permeability of the dielectric. Or this we can simply say it as a dielectric constant. Dielectric constant. Okay. So this dielectric constant epsilon r equal to 1 for air or vacuum, and it will be greater than 1 for dielectric. Okay. So epsilon r will be always greater than 1 other than air medium. Since the dielectric is a medium, so we can say it will be greater than 1. Since epsilon r is greater than 1, what will happen to this E value? So if the denominator is more, the numerator becomes less. We can say E is less than E0. E is less than E0. So since epsilon r is greater than 1, electric field, new electric field is less than that of the previous electric field, that is without dielectric. Okay. Now we can discuss about other parameters, that is what about the potential, what about the capacitance and that. I think you can follow my class. Now we can write about the potential. You know the relation between potential, electric field and distance, that is V equal to E into D. V equal to E into D, where V is the electrostatic potential. V is the electrostatic potential, capital V. Electrostatic potential, and E is the electric field, D is the distance between that two plates. Okay. So when you place the dielectric in between these two capacitors, what will be the new potential? What will already with the battery connected, we have written about the voltage. Now the battery is removed, dielectric is inserted. So what will be the new potential difference? That we can write as V. That is, instead of E, we can substitute this value E0 by epsilon r. So E0 by epsilon r into D. E0 by epsilon r into D, that is equal to V. So E0 into D, otherwise written as V0. So V0 by epsilon r. Are you able to understand? So this is the electrostatic potential. Electrostatic potential. So here we can understand V is less than V0. Epsilon r is greater than 1. So V is less than V0. So potential decreases. So potential decreases, electric field decreases. 2 points we have noted. Then we can come on to the real point, that is the capacitance. The capacitance, we know that C is equal to Q by V, isn't it? C equal to Q by V. So capacitance is inversely proportional to potential difference. So when V decreases, what will happen to C? C gets increases. When V decreases, C gets increased because it is inversely proportional. So the new capacitance is increased in the presence of dielectric. In the presence of dielectric. Okay. Here you should remember that the value of charge remain same. Okay. Once the capacitor has been charged with the battery, that battery now gets disconnected. But the charge remain same in this capacitor. By connecting the battery, the capacitor gets charged. By disconnect the battery, the capacitor has the same charge. So we should note the point as the charge remain same. The charge, that is Q0, will remain same. Are you able to understand? So when the dielectric is inserted between the two parallel plates, we have got it. Electric field gets decreases with the disconnection of battery and potential gets decreases. Since the potential is decreases, capacitance gets increases because capacitance is inversely proportional to potential difference. But the charge remain same. So I can write the new capacitance. What will be the new capacitance? C is equal to, formula is Q by V. I said charge remains same. Already I said when the battery is connected, what is the charge stored? Q0 be the charge stored. So I can write C equal to Q0 by the new potential V. Okay. This again we can rewritten as V is equal to V0 by epsilon R. Okay, V0 by epsilon R. So I can write Q0 V equal to V0 by epsilon. So V0 we can write it here and epsilon R we can write it here. So epsilon R into Q0 by V0. Q0 by V0 we can rewritten as C0. So epsilon R C0. Epsilon R C0. Are you able to understand? So we have got it C equal to epsilon R C0. Since epsilon R is greater than 1, we can say C is greater than 0. C is greater than 0. So thus the insertion of dielectric increases the capacitance. Are you able to understand? Already you may have learned the formula C is equal to epsilon 0, that is capacitance of a parallel plate capacitor, epsilon 0 A by D, that is without dielectric. If the dielectric is placed, we will substitute epsilon R, that is equal to epsilon A by D. This previously you may have learned, where epsilon equal to epsilon 0 epsilon R, isn't it? Epsilon is the permittivity of medium. Epsilon is the permittivity of medium. Now we have to look up to energy stored in the capacitor. Are you able to follow my class? Energy stored in the capacitor also you may have learned. Energy stored in the capacitor. Now energy stored with the insertion of dielectric. So the formula is given by U. U is the energy stored in the capacitor. U is equal to half Q square by C or Q square by 2C. You may have learned, isn't it? Q square by 2C. Now here, before dielectric means we can write U0 equal to half Q0 by C0. This is before dielectric. Okay. Now after dielectric, after the presence of dielectric, the energy stored can be written as U. U is equal to, I said charge remains same. So we can write the same charge Q0 square by 2C. Q0 square by 2C, or else we can write U equal to 1 by 2 into Q0 square by, instead of C we can write it as epsilon R C0. Epsilon R C0. This again we can write half Q0 square by C0 can be written as U0. So U0 by epsilon R. So we have got an idea. Now the energy stored U will be less than U0 because epsilon R is greater than 1. When the denominator gets increases, numerator becomes less. So U will be less than U0. Okay. So the decrease in energy because of the dielectric is inserted. But the capacitance gets increased. This is a concept for effect of dielectric when the battery is disconnected from the capacitor. Okay, that is, we can consolidate the result when the dielectric is inserted. When the dielectric is inserted in between the capacitor, the charge remains same. Charge remains same. Electric field decreases. Potential difference gets decreases. Capacitance gets increases. And the energy gets decreases. Okay. When the dielectric is placed in between the two parallel plates of a capacitor, when the battery is disconnected, Q remains same, charge remains same, energy, voltage and electric field, voltage and energy gets decreases, the capacitance gets increases. Now the second part, as I already said, when the battery remains connected, when the battery remains connected to the capacitor. Okay, when the battery remains connected to the capacitor. So first, initially we will consider the two parallel plate capacitor which is connected by means of a battery, isn't it? So this is the electric field without dielectric. So E0, and now the dielectric is inserted between the two parallel plates. Okay, this is first plate, this is second plate. So now the dielectric is inserted. Here the battery remains connected. Battery remains connected. What will happen? When the battery remains connected, we can say the potential difference, that is the potential difference remains same, isn't it? Potential difference is V0. Keep on connected, that same voltage. Okay, and the charge stored in the capacitor, that will be increased. Charge stored will be increased because the battery continuously connected to this capacitor, so it is continuously supplying the charges to this capacitor. Okay, so the charge stored in this capacitor gets increased. So I can write the Q value as Q equal to epsilon R Q0. Are you able to understand? When the dielectric is inserted, the charge stored in the capacitor is increased by a factor of epsilon R. What is epsilon R? Relative permeability of this dielectric. Okay. Now because of this increase in charge, epsilon R is greater than 1, so charge remains increased. Because of this increase in charge, what will happen to our capacitance? This is same. Okay. What will happen to our capacitance? We know the formula, capacitance C is equal to Q by V. Here Q is increased charge, but the voltage remains same. So we can write Q by V naught. Q by V naught. So I can write Q equal to epsilon R Q0. Q0 by V naught. So Q naught by V naught or Q0 by V0 means we can write epsilon R into C0. Epsilon R into C0. So C is equal to epsilon R C0. So C also gets increases. Okay. C is greater than 0 because epsilon R is greater than 1. So we can say C is greater than 0. So capacitance gets increases. But this reason of increasing of capacitance is different from the previous case. Okay. Previously the battery is disconnected, the capacitance also gets increased. Here the batteries remains connected, here also the capacitance gets increased. But both the cases are different. Okay. And what about the electric field? Electric field also remains constant. Electric field remains also constant, E0. Because V0 is constant. We know the formula, V equal to E into D. V remains constant. D we are not going to change, isn't it? So V0, D same. So obviously this E0 also same. So electric field remains constant. So we have seen when the dielectric is inserted between the capacitor, the battery remains connected. Potential difference same. V0 remains same. But the charge stored in the capacitor gets increases. Because of charge increases, capacitance also increases. Okay. So capacitance increases. But the electric field remains constant. Let's move on to the energy. So the capacitance formula we can find out with the help of this one. C is equal to epsilon A by D. C is equal to epsilon A by D. Capacitance of a medium. Epsilon is written as epsilon 0, epsilon R. Now what will be the energy stored in the capacitor? Energy. Energy stored in the capacitor. Before dielectric means we have to write U0 equal to half Q square by Q0 square by C0. That we have used in the previous case. Here we are going to use the another formula, that is half CV square. Half C0 V0 square. Before dielectric. Why we are using this formula than that formula? Because here both charge and capacitance are changed, isn't it? Charge value and the capacitance value has changed. So we have to use the formula half C0 V0 square. You may have learned two formula for energy stored in the capacitor. It is from the same formula, the another formula has been derived. U equal to Q square by 2C as well as U equal to half CV square, isn't it? So previous case we have used Q square by 2C formula. Now in this case we have used half CV square. So before dielectric we can write half C0 V0 square. And after dielectric we can write U equal to half C V0 square. C, V0 remains same. Half C V0 square, isn't it? So that again we can rewritten as half into, instead of C, C0 epsilon or epsilon or C0 V0 square. Okay? Epsilon or C0 V0 square. So half C0 V0 square can be written as U0 square. So we can write epsilon or U0. Epsilon or U0. So U is equal to epsilon or U0. So what will happen to U value? U also increases. U is greater than U0 since epsilon R is greater than 1. Are you able to understand? The second case, when the battery remains connected to the capacitor, the battery remains same. So the voltage remains same. But the charge is continuously supplied to this capacitor. Charge gets increased. With the insertion of dielectric, charge gets increased. Okay. So Q equal to epsilon or Q0. But the potential difference remains same. Because of charge increases, capacitance also increases. So we can write C equal to Q by V0 and epsilon or C0. So C is greater than C0. Capacitance gets increases and electric field remains constant because we know the formula V equal to ED. V constant, D constant, obviously E also constant. And what will happen to the energy? Energy is equal to half CV square formula. Before dielectric, half C0 V0 square. After dielectric, half C V0 square. So otherwise we can write this instead of C, epsilon R C0 means we can write half C0 epsilon R V0 square, that is equal to epsilon R U0. So U equal to epsilon R U0. So U is greater than U0 or epsilon R is greater than 1. So in the second case we can consolidate the answers, that is with the presence of dielectric and the battery remains connected. Connected. So what will happen to the charge? Charge gets increases. Then electric field becomes constant. Electrostatic potential, that also become constant, capacitance gets increases, and energy U also gets increases. Okay, so here the voltage within the capacitor is constant and electric V and E are constant, electric field also constant. So we can write the energy density. This also you may have learned in the previous class. Energy density is given by the formula small u is equal to half epsilon E0 square, where epsilon is the permittivity of the dielectric material. Okay, so this is the formula for energy density, U equal to half epsilon E0 square. I think you have understood today's class. The summary of today's class is tabulated here in your book. Dielectric is inserted when the battery is disconnected, when the battery is connected. Charge, voltage, electric field, capacitance, energy. Charge is constant when the battery is disconnected. Voltage decreases, electric field decreases, capacitance increases, and the energy decreases. When the battery is connected, charge increases, voltage and electric field constant, capacitance and energy gets increases. I think you have understood today's class. If you have any doubt, you can ask me in the interactive section. Learn this question and try to solve the problem example 1.21. The same concept. Okay, the solutions are given in your book. Try to solve it. If you have any doubt, you can ask me in the interactive section. Okay, students, thank you.